Right. In our calculus, we'll also be asked to find either the equation of a tangent or the gradient of a tangent. It is important to understand what a tangent is. If I have a graph like this one, for example, can be any graph. If I'm using this graph, for example, there is the graph. Let's have a tangent there. This is a tangent. It touches this graph at this point. If the value of x here, for example, if it is 2, you've got two graphs. Let's call this graph the tangent f and call this graph the parabola g. What is happening between f and g at this point? Those two graphs are the same because there's a point of intersection. Ithini lento kuthina? Ithi mangabe ngipressa leli point, ngibuza ubani x ku-f, you will say it is 2. If I'm pressing the same point, ngibuza ukuthi ubani f ku-g, you will say also it is 2. So these two graphs are the same at this particular point because they've got the same x value and the same y value. So the coordinates are the same here. If the question says find the equation of a tangent, what is a tangent? A tangent is nothing else but a straight line. Y is equals to mx plus c. When you are required to find the equation of a tangent, we're just looking at nothing but m and c. What does this have to do with calculus? Because when I'm looking for the equation of a tangent, I'm looking for m instead of gradient. Calculus, ile nto esenza ukuthi sikhulume nge-tangent ngoba there's gradient there, and in calculus we're dealing with the gradient. So this m becomes important as well as c. So we might be required to find the equation of a tangent. But we know at this point, a gradient is a straight line, the gradient is a parabola. At this particular point, they are the same. And it is only calculus that can help us to calculate the gradient at a particular point. So the gradient at this point is the same whether I'm using the straight line or the parabola. Right, let's look at the question that we have here. This is taken from 2013 November national paper. It was question 8.3. The question says, determine the gradient of the tangent. Now, it is important that you should understand the question. We're just looking for the gradient of the tangent, just m, of this tangent of a straight line. We're just looking for the gradient, which is m in this particular case. Determine the gradient of the tangent of the graph of f equals to that. What type of a graph is this? It's a cubic function, cubic graph, at x is equals to minus 1. We're not given the tangent here, we're not given that straight line, but it's still not the gradient here. Sinigoza ukuthi ithinta at x is equals to minus 1. In this particular case, ithinta at x is equal to minus 2. In this case, ithinta at x is equal to minus 1, and ithinta leya graph. In other words, we know that a gradient yale graph, the gradient a tangent will be the same at this position. As it is, a gradient of this parabola and the gradient of this straight line is the same at this point. So mangibuza a gradient yalo line, ngingayithola gradient yalo line at this point, it will be the same thing. That's what we're doing. All right. Do we know the gradient of that tangent? We don't know. Do we know any straight line there? Are we not even given the equation of that straight line? But what is it that we're given here? We're given this cubic graph. And we know that that line touches this graph at this point. And we know that at that particular point, the gradients will be the same. So in other words, if you can find the gradient of this graph at this point, it will be the same as the gradient of the tangent at that particular point. Now let's do that. Uma sifuna gradient, suke senzani? Must differentiate us with the gradient. In other words, if it's a derivative of this one, it will be the same as the gradient at this particular point. Let's do that. Let's find f of x prime. F of x prime is equals to, you multiply that, it's minus 3 times minus 3, it's going to be minus 9x squared. Differentiate that, it's going to be minus 4. Differentiate that, it will be 0. So that's what we have. But we are told over to x ubani. We are told the value of x. In other words, wherever there's x, we push in this particular case, minus 1. So that will give us the gradient of a tangent at that particular time. So m tan is the same as this gradient, which is minus 9 at x is equals to minus 1. In this particular case, minus 4. This will give us the gradient of the tangent. The gradient of the tangent, because it is the same as the gradient of our function at x is equals to minus 1. What is, remember this is squared. This is 9x squared minus 4. So what is minus 1 squared? It is positive 1. So minus 9 minus 4 will give us minus 13. So the gradient at this particular point will be equals to minus 13. For argument's sake, if the question wanted us to find the whole equation, at this moment we only have the gradient. Suppose the question says find the equation of the tangent. We're going to be able to find m and c. Remember, if it's in a gradient and a point, we can find the equation. And if the question says find the equation, not only the gradient, what is it? Bese wenze njani ukuyithola the whole equation? Khumbula ukuthi ukuze sithole equation fanele sibe nani ne gradient ne point. Ukuze sisebenzise equation ethi y is equals to y minus y1, y minus y1 is equals to m into x minus x1. Where m will be your gradient, then y1, no, x1 will be any other point that you have. But since we have a gradient, how can we find another point? In this particular case, obuyokwenza yilokhu. Ubuzothatha lo x lo wakho o minus 1, usubstitute kwi-original equation. This is our original equation. In other words, where there was x, bese ufaka u-minus 1 la, sifaka u-minus 1 this other side. Ukuze sithole the value of y, corresponding y value. Once sinayo i-point, bese soba nawo x o minus 1, no y ozobe siwuthole lawo f of minus 1 plus i-gradient yethu, then we'll be able to find the equation of that particular tangent. Thank you.